Trigonometric integrals. Well, what is crucial to this particular section? Trigonometry. If you don't know how to go between sine, cosine, secant, tangent, you're going to have a hard time. So brush up on trigonometry before you come back next time. We have seen integrals that have sines and cosines. Agree? We've seen them with logarithms, we've seen them by itself. And last time we did a problem where we didn't need integration by parts at all we needed was a trigonometric identity. What if we have a scenario where sine raise m x, cosine raise n x dx, and m and n are integers. Do we know what an integer is? What is it?
It's a whole number.
It's a whole number, no decimals allowed. So problem like this cannot have decimals for m, n, or no. Any thoughts on how you would evaluate? For example, let's pick a simple case. If m is 1, n is 1, life is easy. Do you agree? I know the answer already. It's negative cosine 2x over 4. But how did I get there? Think back like 10 minutes ago. If m is 1, n is 1, it's just a half-angle formula. The integral is going to reduce to sine x, cosine x, dx. Right? But what is sine x, cosine x, dx? Well, I know what sine x times cosine x is. Simply sine 2x over 2. 1/2 is a constant. I know how to integrate sine 2x. Integral of sine 2x is negative cosine 2x over 2. So the answer is negative cosine 2x over 4 plus 6. Agreed? Great. I used an identity, like worked out nicely. Why was it feasible? Well, it was possible because that is a standard identity that we know. And we had m, n equal to 1, correct? But what if m and n are not 1? In other words, as an example, let's say m is 3 and n is 2. Good. How should you think about this? Now, before we get to that, this problem, I could have done it in a different way without using trigonometry. I mean, we are using trigonometry because we have sine and cosine, but what I mean to say is, without using identities, I would have gotten to the answer. Thoughts? It's not going to look exactly the same, but still doable. Use substitution, right? I pick u, doesn't matter which one I pick. No, I can pick this to be u, I'll get that. I can pick that to be u, I'll get this. Agree? So U substitution is a way to go, but depending on what you pick, your answer is going to change. In the sense, they're not going to look like that. But can you get to that step? Yeah, with a bit of work. That's where trigonometry is going to come into play. Why did I bring U substitution up? There is always a reason behind what I do. So, if m is 3 and n is 2, I will have sine cubed x times cosine squared x. Yes? I cannot do this. Do we agree? This is not doable, period. Well, what else can we do? The same problem I said can be done using U substitution. If it works here, it should probably work there too. Do you agree? Okay. It will all come down to how you split that interval. By split, I mean the integrand. Integrand is whatever that is inside. So how you split that part matters. So in other words, should U be sine x or should it be cosine x? That is a major question to answer.
Cosine squared.
Come again?
Cosine squared.
U is cosine squared. Okay. Right, you're already going this way, eating that sandwich.
Actually, yeah, you should be.
I mean, if you're going to pick a power, then that will be a problem, right?
What do you mean pick a power?
No, for you, cosine squared of x, or if you picked U to be sine cubed of x, that's a problem. So it's not a good idea. Did you have something in mind?
No, that totally means.
Oh, it's totally this one. Okay, that's not going to work. So, there has to be some way. I look at that sine. I'm going to rewrite it this way. Go ahead.
Could we perhaps like make sine cubed into something even, like say sine squared times sine of x?
So why? Why?
So that we could possibly apply an identity to it, like 2 sine of x cosine of x?
Very good. I can deal with sine 2x. I can deal with sine squared x. I can deal with cosine squared x. What I cannot deal with is sine cubed x. What I cannot deal with is cosine cubed x. However, I can rewrite it. So I'm going to split this up as sine squared x, sine x, cosine squared x, dx. Good. Well, we have to do U substitution. Caden, what should you be? You could be anything you want. That's what you want to say.
Say sine of x, we're already heading in that direction anyways, since we split it apart, why not make u equal sine of x?
What?
Actually, let's stretch that, make equal cosine of x.
U must be cosine x?
Yeah,
Okay. If U is cosine x, what is du?
sine of x, or negative sine of x,
Okay, and don't forget the dx part.
the x, yeah.
So got U squared, I got that part covered, sine x dx, that's a negative, but you got that problem, right? That needs to go away. I need to convert the entire integral in terms of U. Not good.
Gotcha, yeah. So sine x times sine x squared.
Is sine x times sine x? Absolutely. But what is sine x? You've already used up sin x dx for du, and you replace sin x again. The only way to do it is rewrite it as negative du over dx. So you'd end up having du over dx. That doesn't make any sense, at least to me. Right? No kind of problem. So Hayden was going in the right direction and then dug a hole and jumped right in. U has to be sin x. If u is sin x, what is du? In retrospect, I might change my mind. I take that back. Hayden, did you say cosine x?
Yes.
I take that back. Hayden was correct. Cosine x, sin x, with a negative. So, cosine squared will become u squared. I don't memorize the integral, I go with the flow. That's just my personality. So negative sin x dx is negative du. Good. I have that sin squared hanging out there. Caleb said, well, I can rewrite it as sin x times sin x. And I said, well, you can't do that because sin x would simply be negative du over dx. X is going to come right back in. Somehow, magically, I would like to convert that sin squared x to something in terms of u. Because my objective is to convert that entire integral to an integral in terms of u. Alex.
I feel like it's from the negative du squared. Negative du squared.
That's what Caleb suggested. That you cannot do.
Plug into sine cosine of x.
Plug into sine, cosine. Sandwich going this way. Sandwich is going this way. And you can eat it this way. At least you are thinking about items.
Squared.
D squared. Now let's get out of this D squared business. You cannot put D squared. You cannot put du cubed. None of that is going to happen here. Good? It's either du or dx. That's it. Good? No d squared, no dx squared, none of that. That's it. How do I convert sine squared to a term in terms of u? The answer is right there.
Isn't it like 1 minus cosine squared?
What? Yes.
Like,
You're asking me, I'm asking you. Yes.
like there's the one, I don't know words, but my vocab is awful, but it's like sine squared plus cosine squared is equal to 1. So if you just like flip it the other way.
Very good. Sine squared x plus cosine squared x is 1. That is the very first identity in that table that I gave you. Since sine squared x plus cosine squared x equals 1, I can rewrite sine squared x as 1 minus cosine squared x. Right? Then that integral would simply be 1 minus u squared times u squared d with a negative out in front. Good? Did I successfully convert an integral that was in terms of u, x, and change it to an integral in terms of u? Yes? Okay. So, that is trigonometric integration. Now, here is something that you've got to keep in mind. Before you come next time, understand the identities. The common ones would be half angle, double angle. This one, sine squared x plus cosine squared x. Also, leave the thought of d squared, dx squared. I don't want to hear about it again. Good, that's bad thinking. So leave it alone. It's either du or it's dx. Okay.